Okay, so we have an M1. It's a 13 inches. It's a MacBook Air, and so it's coming in for no power. So we are obviously going to go through how you can assess a device like this one. Um, a successful repair, it's very dependent on how you follow the processes that you follow. And the most important aspect, or the most important factor in your repair, I would say, is being able to identify your device, knowing fully well your device, because some of the know-how or some of the approaches or some of the procedures you'll be following will be dependent on the device that you're working on. Some of these are general. Some of these approaches are general, which means it doesn't matter whether it's an Intel or an M series, but others are specific. A very good example is when you are trying to revive this device. If for some reason the device is stuck in DFU mode, or for some reason the device requires you to do a DFU revive or restore to the device. Now, the port to use, because this is an M1, you are going to use the first port and not the second port. Now, if you use the second port, you are not going to get the device into DFU mode, which would then mean that you would think that, and if you're not able to get the device into DFU mode, you will not be able to carry out the revive or the restore process. Now, if you do not know if the device is an M1 or Intel, you obviously will not be able and then sometimes getting the device into the FU mode can also be tricky. Sometimes, say for example, if you're not sure which port it is, and then obviously you have, it's a combination of keys as well as a power button. So it's going to be Control Alt, your right shift key, and the power button. So you hold until obviously the device boots into DFU mode. Now, if you're not sure which port it is, say for example, sometimes you would obviously put the reason why this is important is even when you use the correct port, sometimes you might not get the keys correct. You might not get it into DFU mode in your first attempt. Sometimes you have to try multiple times to get it into DFU mode. But then in the course of your trying, if you have the cable in a different port, which means even when you did do it correctly, you will not be able to get the device into DFU mode. Okay, so one of the ways you can now, the tricky thing about Apple devices is oftentimes they look very much alike. For example, the form factor of a MacBook 2020 Intel looks exactly like that of 2020 M1. Now, if you don't know right how to differentiate them, so two ways. There are two ways you can easily differentiate them. One of them can be from the model number. So the M series, the model number is going to be 82. See that? So it says 82337. Now that will be very different from the model number of a MacBook Air, which is Intel. Now that's one. If you can just give me a 2020 top casing, not a 2018, 2020. That's a 2018. But let me see what you brought even in the first place. What are you doing? Okay, so as I was saying, it's important that you know exactly what machine that you're working on. If you're not sure, there are a couple of apps that can help you. One of them is a Mac Tracker. I'm just going to see if I have that here. Let's see. I don't know if I have it here. I think I used to have it. Okay, I don't seem to have it here, but I do have it on my phone. So one of the you can use that app, and there are many other similar apps that you can use to tell you, which is basically to type in the model number, or you can even use Google, type in the model number, and then it will give you details of that device. Now, but if you have the device in front of you, one of the ways you can differentiate between them. So these two devices, this we have one that is Intel, this guy, and this is the M1. So other than the color, you will not be able to tell any type of difference between them. For example, if you look at the keys are raised accordingly the same way. So I'm not sure if you guys can see that. You see the keys are raised accordingly the same way. Now the power button, which is also the touch ID, it's exactly in the same way. The side, like they look now. If this was gold, you would not be able to tell the difference between them. However, one of the ways you can spot which of them is an M1 and which of them, or rather, which of them is an M series and which of them is an Intel series, it's just the FN key. So if you look at the FN key, you have the global icon, the kind of like the word icon on the FN key. On the Intel, you will not find it. So Intel, you will not find it. Now, this difference is it's across whether it's a MacBook Air or MacBook Pro. It's exactly the same thing. That's what you're going to find. If you When you put a side by side a MacBook Pro 2020 and side by side a MacBook Pro Intel and M1, they will look exactly the same way. Two port, touch ID, touch bar, touch bar. Everything is going to look exactly the same. However, two things that's going to stand out from the build, from the form factor, is going to be that you will have this icon on the FN key, and the Intel version will not have that icon. And then the other way you can easily differentiate them is also going to be by the model number. You can also use the serial number to basically run a search on whether a device is it's an M series or Intel. So that's it. And again, it's important that you know exactly, because the question will be, if you do not fully understand the device that you're working on, then it would be that you're basically gambling your way through the repair. You have to know exactly what device you are working on. So that is that. So that's just some of the two ways. Now, for example, this one, you will see that the model number of this is going to be A2179. That's going to be the model number. Yeah, it's 2179. While this is going to be 233. Yeah, this is 2020. While this is going to be 2337. Now, the 2018 and 2019 of this version, one of the ways you can tell the difference is the keys are, they use a different key mechanism, whereby, so you see how these keys are raised. Now the 2018, 2019, you have the keys will be as flat as this. So just that, you see the way I press it down. So give me the first one that he gave. The first one, the MacBook, the first top casing he gave me, you brought, he gave you the. So if you can just show them the difference. It's fine, don't worry. Now, if you look at this, see, see if you can notice the key differences. See, one is very flat, and yeah, this is gonna be, yeah. So this design, they have the scissors mechanism and the butterfly mechanism. So basically, they tried one before, it didn't work, and then they switched it back. So if you look at this, for example, you see the keys are very flat. Yeah. Now this design, the first time they had this design was the 2015 on the MacBook, the 12 inches. That's the first time they introduced this design. So they used it on the 2015. They reviewed and still used it on the 2015 they used it, and then in 2016 when they introduced the touch bar on the MacBook Pro 13 inches and 15 inches, they used the same key design. Now, in 2017, they maintained the same key structure, and people really complained about it. But then in 2018, they did the same thing. They maintained the same key structure. However, in 2019, with the start of the 16 inches, because they introduced the 16 inches, which is 82141 in 2019, they then changed the keys back to what it used to be, because prior to 821, prior to F1534, which is the 12 inches in 2015, they had a different keyboard structure from which is the 15 inches, the 13 inches. They had a different keyboard structure, which people didn't complain about. But then they had to change the mechanism from 2015, which is when they introduced it on the 12 inches. However, in 2019, they then change it again. I mean, with the 16 inches. Now that they have kept to that, even with the newer devices, they have not gone back to the revision of the 2015. Now, so if you this keyboard is what they use on the 2018 and 2019. Now, while this is so, this you can just clearly see from the keyboard arrange or from the keyboard that okay, this is clearly different from that, and also it's going to be clearly different from this. Now, the ones that are very difficult for you to differentiate is the 2020, because the 2020 it will look exactly, and also even you see that the power button is raised in order to give you a flush with the keys. Now, this is obviously going to be the same thing. So the power button of this is also going to be flush in a way that it's the same length with what? With the keyboard. So this, you can clearly see that it's going to look different. However, the one that it's a bit difficult for you to differentiate, it's the 2020 Intel and the M1. So that's that. And again, I just mentioned that the in terms of the trying to do revive or restore, putting the device in DFU mode, for Intel, you have to use the second port. And this is the same thing with even the MacBook Pros. The second port is what you use for Intel. Now, the key combinations are the same across. Key combinations are the same, whether it's Intel or M series, the key combinations are the same. However, the ports will vary. For M series, whether it's a MacBook Air, provided it's an M series, you use the first port, obviously on your left hand side, not the right hand side, the left hand side, the first port on your left hand side. The series with two ports, obviously you only have two ports, so you're using from the left hand side. The series with more than two ports, it still has to be on the left hand side. The first port on the left hand side, that is for M series. It doesn't matter if it's your M1, M2, M3, M4. As it is now, currently 2025, as of today, is still on. With the revision of the M4, we're still on the first port for your DFU. Now, for the Intel, you have to use the second port still on the left hand side. Even if the device has more than two ports, you are only to use the second port on the left hand side. If you use any other port, it's not going to work. Now that is that. And then finally, let's say now we saw the difference in terms of the key, the logo on the key, the model number. But let's say if you then happen to open up the device, your Intel MacBook Air will have a fan. The M1 will have no physical fan. So from the inside, even though yes, there will be difference, but the one thing that will stand out for you is if it's an M series, there will be the board will have no fan. If it's Intel, it will definitely have a fan, and it's logical because you have more heat generation from your Intel compared to your M1. Is there any question before we can move away from that? Any question? Yeah. Okay, so like I said, this is coming in for no power. We've just identified that this is an M1. So, and then by the way, this is M1, not the M2. So the form factor of the M1 is completely different from the M2. When you see the M2, it looks very much like a MacBook Pro design. So I'm just gonna see if I can get the M2 to you guys. Let's see if I can get the one that is. It's completely different. It's a complete redesign from ground up. Basically, it's a complete redesign of the MacBook Air. So this is the M2. It's a complete redesign. Now, the form factor of the M2, the M3, and the M4 is going to look exactly the same. So the M1 was so there was just one revision of the M1, 2020, and that's it. There was no. I mean, usually, for example, like the Intel, you have the 2018 version, you have the 2019 version, you have the 2020 version. The 2018 and 2019, it's practically the same machine, with the exception of obviously the firmware, and then obviously you have also the screen the screen differences. But other than that, it's physically it looks exactly the same. That's 2018, 2019, the Intel now. Now, for the M1, there's only one revision of the M1. There's only one revision of the M1 for the MacBook Air. Now the M2, M3 will look exactly the same. This is the form factor of the M2. It looks like a MacBook Pro. Actually, when you say it, you obviously you wouldn't be able to tell. And then again, as we know, say for example, okay, so now so if you look at this now, this is a MacBook Air. And now when you look at it, if you do not know, and also this is also the M2 was also the first time they introduced the Safe 3 on the MacBook Air. So with the M1, it doesn't have a Safe 3 now. So if you and then again, another thing is you will see that the name strip, it's not added here. So here you have the MacBook Air, but here you don't have it. There is no MacBook Air here. But the keyboard structure looks exactly like that of a MacBook Pro. For example, if you look at my 16 inches MacBook Pro, see the keyboard structure is exactly how this is designed. So yeah, so this is completely different. And then also the model number, you can also pick up the model number. So the model number for this one is going to be, where is the guy? 2681. So that's going to be the model number. So this is the M2. So the form factor for the M2, the M3, and the M4 is going to be exactly the same thing. Now the one that stands out completely, which has not been redesigned, obviously, is the M1 2020. Okay, you can just put this aside. We'll continue. Just put them there. Okay. So now, and then the same process follows in terms of the fan structure. The M1, the M2, the M3, and the M4. Still, you find no fans inside. And like I said, from the M2s, that's where they introduced the Safe 3. Okay, so let's continue. Now this is coming in for no power. So typically what I will do is before I will connect power to the device, I'm just gonna be sure what state the device is in, which is basically to open up the back, take out the back cover to be sure that it's not liquid damage. And then again, another thing I like to do is when I'm opening up the back of my device, I make sure I have a guide like this. I use my finger to guide it so that my screwdriver do not slip. Because oftentimes when you're opening, the screwdriver slips, and then what happens is you get a you tend to introduce scratch on the back of the device. And some people are very particular with their device, and they will know when there is scratches to that device. So you try as much as you can to guide your screwdriver. And then another thing I want to say, it's oftentimes you find people that work with their hand not participating. They just do this and then they do this. No, it's bad practice that you only utilize one hand. You have to utilize both hands. Both hands has to participate. Even if you're not using the hand to do to guide your screwdriver, you have to use your hand as a support structure for the device, because you do not want the device to move. And then another thing is, while you're standing up, be very careful because of the way the device is placed. You see the way we place the device like this. Be very careful so that hmm, you do not bump into the device. Yeah, so these are things that you have to be careful about. So when you are standing up, just be very careful. Again, try not to be distracted, because if you are not distracted, at least you will be able to take that into consideration. So okay, let's take out the screws. Now while we're taking out the screws, another thing I just want to mention to you guys, the screw sizes are not the same. And then not only are they not the same, they are also not the sizes are not the same, and the structure are also not the same. So I'm just gonna start from here, so show you guys. I did make we do have a video on this before, which I obviously explained the differences of the screw sizes and types. So if you look at this now, so this, you see the thread are also this you have a longer thread here, you have a shorter thread. The shorter thread, it's this two here. These two here are for the okay, these two are for this and that. Hmm? The ones with the shorter thread. The ones with the longer thread are for the middle. Do you understand? So this longer thread for the middle, this for this and that. And then we are now going to take out the remaining, and then we see what the sizes they are. See how it just slipped? Yeah, so that's very much expected. So which is why I tend to put a guide on it. Now you will see that the remaining screws will look exactly the same. So now, which obviously you can, so which means you don't really have to worry where. So from this point to this point, you see that the screws will look exactly the same. But these four here are different. So the first two with a shorter thread, they will have to be the first and the last. The ones with longer thread will be in the middle. So that's that about the screws. Now let's move on. Okay, so and then and then for me to and then to remove to take out the back cover. So there are a couple of ways to do it. Now, at all times, make sure the device is protected. At all times, make sure the device is protected, and do not be careless. This is important in terms of this means so much to someone and it's being handed over to you. You're supposed to handle it with care. Now, so there are two ways I would do this. I mean, other people do it differently. So some people have like a suction cup to place here to lift it, and while they are doing that, they also have a protective measure like this to kind of hold the device down. Yeah, to do this to lift it. I do it differently. I do this and then I can lift it from here. Now you see the way I do it.
Because I think with the A's it's easy to lift them from
Yeah,
there.
yeah, yeah.
It's
Now
not
with the
always the
Pro,
easy.
with the Pro, I would do this with the Pro. That's what I would do. So I'm just do that, and then that's it. The back cover is out. Now with the back cover out, what I typically would do is I'm gonna use the back cover for my screws and hold whatever comes out of the machine. I'm gonna put it on the back cover. So then the next thing I also want to do is I also want to put anything, especially but for what we do is we use date for date and the client. So for this one, we're just gonna do F3, and then today's date is 16, correct? 16, 10, and then 25. Okay, so and then so we kind of make sure we put something on each, and then including the logic board just to be okay. So that's that. Now after that, he's on the next thing we want to do is we want to make sure that the battery is disconnected. Now you see this is the space for the fan. The fan is clearly not present. Now another thing also it's the battery the battery cable to the board on your M series. You will find it here, and also you see this particular clip, this clip system. uh, this clip system was only used on the M1. No other machine has it. The clip system, it doesn't exist, only on the M1. And then also I'm talking about this slash here. I'm talking about this slash, this one here. This is what I'm talking about. You only find this on the M1. Okay, now and also on the M, if it's an Intel, the battery cable is going to come from here because it will connect to the board from the side, not from the side. Okay, so that's that. So the first thing you're going to do is what with your with the back cover out, you want to disconnect the battery, which is what I obviously had to, and to do that, you obviously have to release the lash. And now remember, this lash has, let me show you that. So it usually clips here. So you see that clip there? Yeah, so I'm just going to show you. So that when you see that? See? So you want to release that clip, then you can lift. And to connect the battery, usually the way you do it is you start from the back like that, slip it in, and then you push down. Do you understand? So I will do it like this. So I will do it like this. First clip it in, and then I put it down. Just put this out. So because of this section here, so I'll typically put it from the back first. So like this. Hmm? So once that goes in, and then I can close it. Okay, so that's that. Okay, so now that the battery is disconnected, the next thing I'm going to do is I'm going to make fairly basic measurements. Basic measurements is I want to see if I have a short on my PP bus. That's typically what I'm going to do. Now I can choose to use my diode mode, and then I can choose to use continuity mode. Diode mode will give you values on this on your multimeter. From there, you can determine if your values are low or your values are the right ones. If you're not sure what value you're expecting, you can obviously use a reference board. Then continuity mode is going to be, and this is going to be the sign for your continuity. So that is going to be the sign for your continuity. Now for my multimeter, I can switch to diode mode, and that's the sign for your diode. So diode, continuity, diode, continuity. Okay. So the next thing I'm going to do is I like to use diode mode because it's more accurate for me. I mean it's more accurate, and I like to use diode. And the next thing I want to do is just so that you guys know what we're measuring. So we are going to open up the board view. I suppose. So let's open up the board view. This is going to be 820-21 to 2016 0216. So it's 820-02016. So this is the board view. So the first thing I'm going to do is I'm going to see what I have on my PP bus. So you see where it says PP bus underscore AON, and AON is going to be your always on. Now, just something that I need to mention to you guys. So you see, this board here, this is the audio board. Now, this audio board houses the audio jack. It's also where the power button connects to the logic board, and you will have a cable that runs from Mark. Okay, I'm just gonna phone him. You will have a cable that runs. Just see this 198.1.9. He's mentioning that the audio board that you have here. On the audio board, you have the speaker amp. The speaker amp has capacitors around it. Oftentimes, this capacitor fails, and sometimes the speaker amp also fails. Now these capacitors are on the PP bus AON line, and that is connected to the board through the cable that you have here. Now there are two cables here. You have one from the Touch ID, which is this guy here, your power button, as well as the Touch ID. You have the other one. Obviously, that's the cable that carries your data as well as power to the board. Now that board, like I said, it houses three things. Your right speaker is also connected to that board. You have your touch ID, your power button is connected to that board, your audio jack is connected to that board. So that board is going to have power and data. Now sometimes you will have corrosion or oxidation or something happens on this board. So when that happens, you will have a short on this board, which would then interpret as a short on the main board. Now, one of the ways you can now, if I measure for a short on my board and I have short on PB bus, the first thing I'm going to do is I'm going to disconnect the audio board. And how do I do that? I just need to take out the screw, which is I'm going to show you guys. And the guide that I talk about, you want to use that procedure across the board. And the same thing is, you also don't just want to do this. No, you want to have some kind of protection for the device. You use this, yeah, as a form of protection to the device to ensure that the device doesn't slip. Okay, so this is the cable that I say that runs from the logic board. So what I need to do is, and then again, especially when you're not sure about if it's the first time you're attempting any type of repair, use your fingers to do disconnection of your cables, because that way, if you're going to rip off anything, if you're using a tool, you might not know the amount of force that you're using, but if you're using your fingers, now there's a less chance of you actually damaging something, because you will be able to feel it to know exactly what you're doing. Now the first cable, which is this guy here, that is the touch ID and the power button. And then another thing that you see that usually one of the ways you can tell uh, okay, so usually one of the ways you can tell that a particular cable is coded, it's by that. You see that? So, yeah, the barcode. So, uh, although that's not a unique sign that okay every but then this touch ID, it's programmed to work with this board. So if for any reason you're replacing this board, make sure the touch ID is also replaced. If you do not replace the touch ID, the power button function is going to work, the power on the click to sleep is going to work, click to lock is going to work, but the touch ID is not going to work. Now this is the cable that I'm talking about. This is the one that obviously carries power and data to the board, and because of this is a bridge between the mini board here and the main logic board. If you have a short, especially on the PP bus on this line, it's going to be interpreted on the. So what I will do is, if I disconnect it, for example, what happens is I no longer have communication between my power button and this. Now, say for example, you find yourself somewhere. Now, another thing I want to say is, if one of these cards fails, you can just use anything just to remove the card that has failed, and you just continue. The machine is going to work 100%. Every of the function here is also going to work. Even if you have two of the cards that have failed, you can remove two of it, and it's still going to work. Now, let's say for some reason that this cable is damaged beyond repair. There is nothing you can do to to the board, not the cable. And what you can do is you can disconnect this. You can disconnect the cable. What's not going to function on your device is the left speaker is not going to function on this device. Now, this is an amp. This is this section of the board is not obviously what's not going to work is your power button is not going to work. So touch ID is not going to work. The audio jack is not going to work. Device, and then obviously you have that. But then the device is still going to work. Now you might ask yourself, how do I power the machine on? Now, this machine is designed differently. Your lifting the lead will activate power, and the trackpad will activate power, the keyboard will activate power. So just by lifting the device will start. Just by clicking on any of the keys, the device will start, provided it has standby voltage. And if you want to shut it down, you can shut it down from the operating system. That is in a situation where you find yourself that you cannot get a board at the moment, so you can just have the cable disconnected, and then you have a working device. Because I mean, other than that, you have a board that is not working. It has a short. You cannot use the device, but then you can have it disconnected and use the device for the time being while you source for or you source for an audio board. So that is that on that. So the first thing, obviously, this is in a situation where I say if you measure and then you find that you have a short on the board. Now, to check, the first thing I'm going to do is I'm going to check to see if I have a short on my PP bus. So this is my PP bus line. You see where it says PP bus underscore AON. Now on my logic board, that would interpret into, this is a capacitor. The capacitor that we can likely use is C5963, or we can use C5962. So it's either this guy or this guy. Now on my main board, it's going to be this guy and this guy. Now there's something else that you see that on the capacitor you have a print here, yeah, and you have our print here. Now that will symbolize the pin 1, and that's the main line. That's the line that carries voltage. That's you have here you have power, and then the other side is going to be ground. Now there are two faces to it. There obviously it has two terminals, 1 and 2. This is going to be main, and that's going to be ground. Now this is a polarized cap, meaning it's a directional, so it works with direction. So when you're replacing it, this direction has to be put into consideration. You see that marking that symbolizes your pin 1. So also if you look at if you see here, you see there, see that's where it says pin 1. Now you have other caps on the board, which is, for example, this guy CC334. Now this is a non-polarized capacitor, so it's for this type of capacitor, which is this guy here. No, sorry, not that one, not that one. That's also polarized cap. That's actually a tantalum capacitor. That's not, I'm not talking about, not this one. Okay, we can use this guys here, the ones for the backlight output. So these guys, these are non-polarized capacitors. So what that will mean is they are not, they do not work with direction. Whatever way you flip them, they are they are going to work. Now that's not the same with this guy, this guy, this guy, this guy. They are not the same. This guy here. Now this is an inductor. This is an inductor. This is going to work exactly like this in terms of the direction. However you flip it, you're still going to be fine. This is also the same thing. Now that is a diode. Usually also diode will have what is called markings also. Now this particular diode also has marking. You have to make sure you orient the diode. So with that diode you will see. So where's the diode? This is the guy here. This is guy DP800. So you see DP800. But with this guy, I suppose you don't have to worry about the diode. Actually, don't worry about the diode. Let's just stick to the capacitors, the polarized and the non-polarized. So when we do diode, then we can delve more into. So for now, just don't worry about the diode. So that's that. So the first thing I'm going to do is I'm going to put my leave my multimeter into diode mode, Then I'm going to have now. Obviously, if your multimeter is set to diode mode, the way you place your probes is not going to be the same way you place them if it's in continuity mode. So if it's in continuity mode, if it's in diode mode, my red is going to be to ground, and then my left is going to is the red is going to be to ground, and then the black one is what I'm going to use on the component. So for my PP bus, I can use this terminal here. Remember that is the tab, that is the main, yeah. So I'm going to use that, not the other side, which is ground. So here I'm going to see what I have. I have 051 8. That's high enough. That's high enough. Now the next thing I'm going to see is I'm going to see if I have a short on my 5-volt line. So my 5-volt line on this inductor, I'm just show you now. This is a 5-volt line. Yeah, I'm going to see that's a 5. So it sees where it says PP5 underscore S2. That's my 5-volt line. I'm going to see if I have a short on that line. So left, and then see if I have a short on that line. The reason why I'm using this capacitor here is because that line is connected. The inductor is connected to those capacitors, you see. So I can use this side, and it says 0300. That's high enough. That's not a short. We're just gonna do random checks to see if we have anything that stands out. Right now, we're not going to worry about the backlight capacitors, because now the backlight capacitors, these are going to be secondary. Yeah, even if you have a short on this line, the device is still going to start. The only thing that will happen is you will not have a backlight, but the device is going to start. So we're not going to worry about that. So typically, if I don't, that's main. That's the side of it. That's on my PB bus. We've checked that. We checked that. We don't have a short. So the next thing I'm going, and usually the first measurement for short that I do, it's preventive measure, just to be sure that there is no it doesn't exacerbate the process. So whatever form of damage that is present on the board. So now that we've confirmed that we don't have a short, the next thing we're not going to do is connect charger to it, plug power to it, and now see if we have, let's see what voltage that we have on the board. And then obviously we are not going to flip our multimeter to voltage mode. Let's connect charger to it. So we connect charger to it. Now charger is connected. Now let's see what is it that we have on our PP bus. So we're expecting to have 12.0 in our PB bus in the working state. So let's see what is it that we have on our PP bus. PP bus, we have 0024 on one port. Let's check on the other port. Same thing. So what? Let's so that's A. Let's flip it to B on the other side. Same thing, and then the other side. Same thing. Okay, so now at this point, what I'm going to do is, I mean, if I don't have PP bus, it typically means that I have an issue. I have to basically start my troubleshooting from my PPDC in. So in order for me to do so, I definitely need to take the board out. So from this point, so I'm not going to worry about trying to measure anything else, because my CD3217 in this case is going to be CD3217 is on the other side of the board. And just show you guys what I'm talking about. So these are going to be the CD3217s on the other side of the board. So because this is on the other side of the board, and the board obviously is oriented this way, so the next thing we're going to do is, if we don't have PP bus, we're just going to remove the board, because if we don't have PP bus, we have to start our journey from the PPDC in. So let's quickly take the board out. And by the way, this is coming from another repair shop, so most likely there's been an attempt on the board. And then for this, to take the board out, you are going to need a T5, a combination of a two screw screwdriver set. For the outside, you need a P5. For the inside, you need a T4 and a T5. It's a T5. Can I have a T5? Okay, I think I've got money. Okay, it's fine. It's fine. Okay, now you see, if this was a MacBook Pro, I would remove this instead. I'll leave the DC jack in place. But because it's a MacBook Air, typically what I do with the MacBook is I remove it from, I take this out and remove the board, leaving the DC jack on the board. Okay, screws are out. The next thing I'm going to do is, and then by the way, just here, the Touch ID is on this board, so there's no need to disconnect the Touch ID. The Touch ID is on this board. We are not busy. There's nothing we're doing here. The only cable that needs to go out is this guy here because yeah, but this stays because there's nothing to do there. So then, and the next thing we're going to do is now disconnect the cables. And again, I said it's best to use your fingers to do the disconnection of your cables because if there's any type of damage, you'll be able to tell using your fingers, especially if it's the first time that you're doing it. And then just see something. You see how I disconnect the cables for the Wi-Fi cables, yeah. So I so although these are more stronger compared to the older design where you have the tip falling off, but even at that, be very careful. And again, do not put this under here. Obviously, you are going to damage it from what from the board. So basically, you want to do this anyway. Okay, so lifting out the board, you make sure every cable is out of the way. You don't force it out. Be sure if there's any type of resistance, check to see what is causing the resistance so that you don't damage anything. Okay, so now we're going to put aside the board, put the board aside, and yeah, take this from there. Put the shell aside, and then put this aside. Okay, so this is the other side of the board. Let's see what's going on here. So typically, like I said, yeah, I'm very sure there's been an attempt here. Yeah, it looks like the board was kind of cleaned with some kind of I'm not sure what it is. Yeah, like I said, this is coming from a repair shop, so they obviously will try to see what they can do to get the device resolved. So what I'm going to do is now, remember we already checked, we found that we had 0 point something on the PPD. So now let's see what is it that we have on our PPDC in. So we are going to be using the fuses. These are your fuses, the PPDC in fuses, this guy and that guy, to see what is it that we're getting through this port. So whatever we connect, we want to see what is it that we have on our PPDC in. So let's check with that and see what we have. Oh, by the way, we did not confirm that our charger itself is connected. So what we can just do is we can use this guy here, but let me see, it's the box. Okay, it's fine. Just so that we can confirm that the charger, we have a voltage on our charger. Let's do this. What's that? Oh yeah, yeah. Okay, let me just put, is it, let me see, is this connected? Yeah, yeah, okay. Yes, use my device to be sure. Okay, yeah, charge, it's connected and fine. So yeah, there's no need to worry about that. Okay, so let's see what is it that we have. Multimeter is set to voltage mode. So let's see what is it that we have. And then I was saying something about the fuse. So let me show you guys on my board. Flip the board to the other side. Now this, see where it says FF, so that's going to be a fuse, yeah. And then you see what it says PPDC in. Okay, and then you have what it says AON and switch. That's a PPDC in AON switch. And you have that, and then you have the other one that says internal, yeah, int. See one side says internal 0. So and HV is going to be your high voltage. HV is your high volt. So PPHV high volt line, internal. You see there are two sides to it. So one, it's just PPDC in. That's basically where the switching. So PPDC in switch. AON is your always on. PPDC in, that's basically your voltage that is coming in. DC, obviously PPDC in, and then you have the other side which is PP HV, high voltage in internal, as internal section of it, so obviously that then obviously work with your UF, which is your CD3217. Okay, so let's see what is it that we have on our PPDC. We already have the charger connected. Let's see, is the mic still on? Okay. Let's see, what do we have on here? We have 0 volt. Okay, that's very interesting. And then the other one, we have 0 volt. Okay, just let's just confirm again that our charger is connected. Let's see. Okay, charger is connected. You heard the chime sound. Okay, if indeed we have, if let's just check again just to be sure that we have 0 volt. Uh, 0 volt. Okay, but then what do we have on the LDOs? Let's see what do we have on the LDOs. 1.8, 1.1. Okay, and then the other one. Remember, one we're supposed to have 3 point something and 1 point something, yeah. But then we have 1.8 and 1.1. Okay, let's check the other one. What do we have on the LDO? 2 point something and 0. Which one would you think is our problem? Remember, so here we have, so this one we have 1.8 and 1.1. Actually, I feel like something is heating up. Let's see, what is that? Okay, one of the CDs. Okay, the CDs are heating up. Okay, if that is the case, now we just obviously we have 1 point something on board. So now let's check for short. So checking for short, I'm going to use diode mode, and I'm also going to use this as a reference just for you guys to know. And then just switch to diode mode and show you guys what we're supposed to have. So let's check on, when I say LDOs, I'm talking about this guys here. Now this the LDO will be connected, so it's connected to your CD32. So I'm going to be using this guys to confirm the working condition, not this one here. That's not directly to the CD. So, but I'm only going to use these two capacitors, this guy and this guy. And then as you see, I'm only going to be using their main. Obviously, this is ground, correct? And this is the one that is connected to our CDs. So let's have, we are using diode mode. So we're going to have our red probe on ground, and our left probe. Let's see what is it that we have here. What do we have? The first one is 0.030. That is definitely a short. I mean, this is what you're supposed to be having. Just give you guys an idea. On the same line and another board, you're getting 0.483. Now, and let's check on the second one. What do we have on the second one? Second, you have 0.061. That's also very low. Now, this is what you're supposed to get on the other one. 0529. Now let's check the second one, the second CD3217. The first one, what do we have? We have 0.032, and the other one we have what? 0539. Okay, so that's interesting. So if this one we have, remember the concept from yesterday. So we say that if our issue was only on this one, then chances are that we might have a faulty capacitor, correct? But in this case, it's here, it's low, and this other line is, and these are two separate lines. So, but then on this one, we only have one being low, but the 1.5 volt line is not. So, 1.5 volt line on the first one, and the 3.3 volt line are both low. But this one here, 1.5 volt line is fine, the 3.3 volt line is not. So in terms of which to remove first, we are not going to worry about removing the capacitors, because like I said, if it were the capacitors, oftentimes one of them is going to be your issue. But in this case, both are low. If both are low, what is the thing that they both share in common? This guy here, CD3217. So the first thing we're going to do is we're going to remove this guy here. Now, but what I don't understand is usually you have, yes, you do sometimes get both CD3217 failing, but it's not usually that is usually from an external source. So you connect a faulty charger or whatever, any type of over voltage. Now, so okay, let's remove this guy here and then see if we still have a short. We're hoping that. So the reason why we're starting with this one is because this at least has both of it being low, while this one of it, this is low, but this is not. So let's start by removing U F400. Do you guys have any questions so far?
I was needed one unaffected on one side. Is because it is three concepted because one is connected, one with the pest is connected to because the pest is because they don't affected, then it can also be
What's your question exactly?
is what it failed the capacity at the bottom low because this one is a low. In yesterday's video, we clicked on one of this. There was
Is
a line that was connected.
Are you talking about the last one? This is not. Did we check that? We didn't check that because obviously we're only concerned about the LDOs, so that's fine. That's fine. That's fine. So we only concerned it's this guy here. These guys here.
You can also ask at that.
And now, so by the way, usually when you wanna just make sure when you wanna heat this section of the board, yeah, it's very good. It's make sure that you remove that. Otherwise, what happens is when you're heating, the weight from this pulls it down, and then it just melts off the board. So the charging port is just gonna melt off of the board. So when you're gonna walk around there, you have to remove the DC jack. Usually, if you don't remove it, what happens is it comes off with the connector, which means yeah. So obviously you can easily replace it, but I mean it saves you time on the other things that you're supposed to do. So okay, so that's out. Let's check to see what is it. And then obviously another thing you have to know is just now that you've removed the component, the board is going to be in a state whereby if you're to read the board immediately, especially in diode mode, you will get the value you get is going to be slightly incorrect. The more temperature you have on the board, the more the value you get will be incorrect. So you have to give it a bit of time to cool off before you do your measurement. So, but nonetheless, let's see. So we check with this one because obviously we know what that was. We know that was fine. That's the first one. So the second one, let's see what do we have on the second one now. Now it's fine, and then the other one, OL. I mean, does it make sense why the other one is OL? Yeah, because there's nothing on that line. Yeah. This guy here, there's nothing on that line. It's just basically here and there. So there's nothing there, so it's going to be oil. But here, even though this is not there, there are other components that are connected to it. So that's fine. Now, what you want to do now is let's see what you have on the second one, which is this guy here. Let's see if that one is still low. If it is still low, then unfortunately we have to replace. But before we replace it, what we are going to do is because it's only one, remember, because it's only this one that's affected, we are going to remove the capacitor first before we remove the chip. Do you understand? But with the other one, we had to remove the chip because both. So let's see what we have. It's too low, and that it's fine. So what we're going to do is we're going to remove the chip, the capacitor first, and then measure.
Hello, hello. You must be so happy. Everyone miss me in this office. Everyone miss me in this office. Today I don't give anyone leave. Today no one must ask for the leave. No one.
Paul, how are you?
Ah, poor boss is here. Anything for poor people. Don't laugh. Don't look at me. Just focus there. This one, the eyes is dead already.
Okay, so what I'm gonna do is I'm just gonna check that cap, even though I'm not so confident that the cap has failed. But then again, I wouldn't understand what has happened here. So, but I want to hope that the cap fails so that we don't have to replace that. But anyway, let's see. So let's see what do we have on both sides. We're supposed to have OL, but let's see. Yeah, OL. Yeah, that's exactly what it's supposed to get. And if you to check the line, yeah, it's still low.
Alex.
Okay, so let's see what else do we have on that line that we might want to consider. Actually, you see now, so which is remember we spoke of something about the master and the slave. So this guy now is going to be dependent on this guy because this is the guy that has direct communication with the ROM chip, correct? Do you understand? So because if you see this one here, it has direct communication with your CD3217. The same one on the other side, it has communication with your what? You have a line with the ROM chip. Okay, so unfortunately we have to remove it. We're hoping that that's not gonna be the case, but yeah. Okay, so that's out of the way. And now we have to replace. I have one here that's already out. Start from this guy. Well, I'll be with you shortly. Just give me a few minutes. Okay, let's get another one. And then another thing I just want to mention, you see the print of this one that we took out from there. It's typically different from. You see the print is different, but then that doesn't mean you can use a different print on it and it's gonna work. You can have that print and that print, but the most important thing is it has to be CD3217, not CD3215, and it has to be 17, not 18 also, because if it's 18 has the same footprints, but they are not. You cannot interchange them, and this is 17, not 18. Let's get another one. So we have one on. Let's get another one. There's nothing here. Okay, we can take one from this guy here. We can take one, and also this is a Pro. Even though this has some kind of a liquid, but so I suppose we can still use it. And I suppose you guys remember what this is, yeah? This dot here. You know what that stands for? Yeah, that's a pin one of the chip direction. Yeah, so it's important you know that. So we're gonna take from a Pro, but obviously when you're putting it there, we have to flip it because with the Air, you see it's flipped the other way around. Yeah. Oh, by the way, when we took that out, we didn't check again to see if we still have a short, but we definitely. I mean, that's the only thing on the line, so it's not like. But we are still gonna check just before. We're gonna check to be sure. That checklist. So, obviously, for me to install it, I have to flip it the other way around, yeah, because this side it's yeah, a little bit of time to cool off. Flip it the other way, yeah, because if you put it I mean, if you put it not in the same, that I mean, if you don't put it appropriately, it's not gonna work. Uh, Wait, let's be sure that the dot is on the right side.
No,
It was wrong the first time.
3 pin, 2 pin. You check under there. You find 3 pin, 2 pin. You first you don't even check on that.
No, no, no. You have to show them
Oh,
with
then
the pin. Yeah.
yeah,
They are young, young. They are just stubborn.
yeah. Oh, you must check the numbers and take
uh,
pictures. Old fashioned.
uh, yeah, but I mean, people have to start from somewhere.
So I'm got too much babies. Why last month too much?
Okay, so we're just gonna try flip both of them in place. And the other cap that we took off, okay, I don't see it. Let's just take another one. And we can look for that later. Obviously, we know that that cap was not our problem. So, and it doesn't matter which of the cap you take. You can take the first one, the second one. It doesn't matter. And it doesn't have to be from this board. Also, you can take from a different board. Also, it doesn't matter. Okay, just another thing I want to mention while the board is cooling off. Usually, when you're taking out, especially a chip that is slightly big like this, you have to be aware that there are components around it. And usually, when you use your tweezer, oftentimes, say for example, if I want to take the chip from here, see when I grab it, oftentimes, sometimes, and remember now that the board is soft, it's melted. So what happens sometimes you move a component and sometimes it can be a data line, for example, like a 3.3 volt data line from a resistor. And then what happens is you move it slightly. I've actually had a repair like that where the person did everything okay, but just that they moved the resistor, which is an important data line resistor, and then the device did not work. So they made a mistake by undoing what was not an issue. But then after they resolved the issue, the device still did not work. So just be aware when you're removing. Just make sure you don't. And he also he usually stresses the same thing. For example, especially on your ROM chip when you're trying to remove to reprogram, you take it off, but then the resistors around it you move it just slightly, and you don't even know. And after you reprogram it, you put your chip back. Your chip is not recognized by your board because you have a resistor that is missing. So, but that's just something that you guys need to be aware of. So when you're removing any of these guys, and then also try, obviously make sure you're working from a stable station so that when you're moving it, the chip itself doesn't move, because once it moves, the components around it will also be moved, because at that time the lid on the limb already are soft because of the what you have applied. Okay, so let's just see now what is it that we have on our diode mode across board. So red, blue, and brown, and then let's start from here. The first one, we know obviously that was fine. The second one, what do we have? Now we have something higher than what we had before, and then that guy, which is fine. And then this guy here, that's also fine. And then this guy, that's also fine. Okay, so let's now we're now gonna put a charger to it and see what is it that we have. Okay, let's switch to voltage mode. Let's see now 3-volt line, what do we have? We have 3 volt, that's good. And now 1.5 volt line, what do we have? 1.5, that's good. Let's check the other one. 3-volt line, that's a problem. Okay, and then the other one, what do we have? 0. Okay, so we're not sure if the liquid affected. Okay, can you see that? It's, yeah, that's where we took it from. Okay, so we have to, unfortunately, we have to remove that and take another one. I was hoping that it's gonna work even though it's, but then another thing is, maybe if we clean underneath it, because I didn't even check underneath it to see what it looks like under. See what it looks like under. Doesn't look bad under. Okay, so let's just get another one. Uh, should we take from here? Okay, let's just take from here. Saves us the time. Obviously, there are two ways you can do this. You can remove the old solder, and you can also try to just put it back without having to remove it. And that's very much dependent on how it was removed. Okay, let's give it a bit of time to cool off. Okay, let's check to be sure that it's properly replaced. Same to verify. Same to verify. Okay. Give it a bit of time, and we can check. This guy, what do we have? That's 3.3, 1.8. Let's check this other guy. 3 volt line, what do we have? We have 3 and then 1.5 volt line. What do we have? 1.5. Okay, now let's see. So usually I don't start by checking the 20 volt line because I mean that's the ultimate check to know that it's fine. But then I just try not to give myself a heart attack on it because I mean I don't want to. I better check the LDOs first before I check. So now let's see what is it that we have on our 20 volt line. Hopefully we have 20 volt. Okay, that's a beautiful 20 volt. I'm just gonna, I mean, obviously it's set to, it's 20 volt or something. That's why you have no L. So we're gonna put it on 200 volt, and then that way we can get our 20 volt, 24.2. That's great. So I'm just gonna quickly put it on the show. Just see that. Can I have the back screws for the back? It's move quickly now because of time. Bring the box for the screens for him. Does he know what you're talking about? Yeah, of course, but he should know. I mean, are you going to take your stock and give to somebody? Why don't you give him the car key also and the office keys? I mean, he knows him by now. It's not the first time that he's coming here.
The light.
So I'm only going to put the cables that I require for testing. So I'm just going to have trackpad screen and then obviously the DC jack. Can have one cable connected just so that okay. You didn't have to connect the battery because we don't need the battery for this testing. Okay, so you guys can see we have Apple logo, we have trackpad feedback, and that's about it. So time is not by our side. So and also it's time for prayers now, so I need to leave. So yeah, that's about it. This was a repair that required board CDs were obviously damaged. I'm not sure what happened to the board, the wire board. Usually you have one damage and not both. So the next thing we're going to do is obviously going to clean out the residue of the flux that was used, make sure the board looks okay, presentable, put it together, test it, and then it's on its way to the owner. Okay, that's about it, guys. Thank you so much. I'll see you guys in the next.